I think she knows, but for those who do not know, what the is the Gram-Schmidt process? The Gram-Schmidt process is simply a way to improve a basis of a vector space. So we are given a basis that is bad in that the vectors are not perpendicular to each other, and we are going to construct a new basis for the same vector space where all the vectors are orthogonal, perpendicular. For example, in the case that the vector space is spanned by only two vectors, v1 and v2, what we're going to do is, well, just keep v1 or a multiple of v1 and then replace v2 by a vector that is perpendicular to v1. And how do we do that? By decomposing v2 into two vectors, one that is in the direction of v1 and one that is perpendicular to v1. Those are w1 and w2. And there are formulas that do exactly that. Those are the formulas that appear in the Gram-Schmidt process. So in this case, what we have done through the Gram-Schmidt process is find a vector w1 that is in the direction of v1 and a vector w2 which is perpendicular to w1 and such that v2 is w1 plus w2. And now I can replace v1 and v2 by w1 and w2 because those equalities show that they actually span the same vector space. Now, the benefit is that w1 and w2 is a much better basis because they are perpendicular vectors. So the Gram-Schmidt process is precisely the algorithm that brings you from the bad basis v1 and v2 to a good basis w1 and w2 of orthogonal vectors. And in fact, there is one last step, which is scaling w1 and w2 to some other vectors of length 1. So these are orthogonal and of length 1. So it's what we call an orthonormal basis. Now let's do this again, but in 3 dimensions. Start with vectors v1, v2, and v3, which span some vector space. And we want to find an orthonormal basis that spans the same vector space. First, take a multiple of v1 of length 1, that's w1. Now we do the Gram-Schmidt process on v1 and v2. So I'm going to replace v2 by a vector that is perpendicular to v1 by doing a decomposition of v2 into this vector and that vector over there, and I'm going to keep this vector as my w2. And now we're going to finish the Gram-Schmidt process by replacing v3 by a vector w3 that is perpendicular to the plane generated by w1 and w2. How do we do that? By coming up with a decomposition of v3 as follows. First of all,